Hi, Steve Hughes here. So in this video, we're going to look at angular momentum and the conservation of angular momentum in relation to neutron stars. Now, we're familiar with linear momentum, so you might be riding a bike and you stop pedaling and the bike still goes on because of the linear momentum. I can just make myself go around like that, so I'm rotating around and I'm not actually touching the ground at all, so I'm still moving because of angular momentum. A bit of extra angular momentum there, and I can get rid of it by putting my feet down. Now, what happens in a what's called a type 2 supernova explosion, when a big star comes to the end of its life, it's got a iron core with a radius of about, say, 1,000 kilometers, and that, in an eye blink, that shrinks right down to something like a radius of 20 kilometers. So that's like going from here to Canberra, that distance, and shooting right down to 20 kilometers. And in that shrinking, there's a rapid increase in the rotation rate. So neutron stars spin very, very fast, 10, 20, 30 or more times each second, because they've got that angular momentum from the core of the star from before it collapses, and it's still preserved in the collapsed core. Okay, so I'm going to try and demonstrate that now. So I'm going to put my arms and legs out like that. So that's like the core, and then I pull them in and I'm going much faster. Then out again like that. So that's conservation of angular momentum.